Today's lesson is on linear versus exponential. In this table right here, this is the meat. Oh, let me pick a different color. This is the meat and potatoes. So for linear functions, they are based on repeated addition with the slope. And exponential is based on repeated multiplication by using the same base. So those two things, definitely need to write those down. That is like the core of what we are learning today. So I'll give you a moment to write that. Okay. So let's check out these two tables. One of them is going to be linear and one's going to be exponential, and we're going to describe why. So as we can see, our x is consistently going up by 1 for both of them, so we just need to analyze the y values. So here we're going up from 5 to 10, and then 10 to 20, and 20 to 40, and 40 to 80. So what is that pattern? Well, it's not addition, it is multiplication. Each time we are multiplying by 2. So this is going to be exponential. Because we are multiplying by 2. But the next one, let's see, we're going from 8 to 11, 11 to 14, 14 to 17, 17 to 20. Each of those times we're increasing by 3. So this is an example of a linear model because we add 3 each time. So there's a clear example of one's multiplying and one is adding. So now it wants us to find the equations for each of those. So with exponential, it's pretty nice because all of our exponential equations are going to be in the form, for now, let me pick a different color, y equals ab to the x, where a is your starting value, like your original amount, that y-intercept, and b is whatever you are multiplying by. So if we take that into consideration, we're going to have y equals, our y-intercept is right there at 0, 5. So it's 5 times, we're multiplying by 2 to the x. So our initial times whatever we're multiplying by each time raised to the x, which with last lesson we were doing, that exponent was a representative of time. So if you pull out your notes from last lesson, you'll see some similarities there. With table 2, that's just a linear example, which we've been creating those equations for a while. So we have our y-intercept at 0, 8. So remember, a line is y equals mx plus b. So we know that it's going to be plus 8. So now we just need to find the slope. So remember, slope is change in y over change in x. You just have to pick 2 pretty points to find the slope. So I could do like 11 minus 8 over 1 minus 0. So we get that value of 3, which we did see was that repeated addition each time. We can use that shortcut because our x's were going up by 1s. But if it's going up by like half or 2, then you want to use your change in y over change in x. So therefore, the equation for this is y equals 3x plus 8. So hopefully that looks familiar. Now I'm going to go a bit out of order with today's lessons because I want to practice a couple more tables before I do anything else. So I'm actually going to scroll past that. I'm actually going to do some of these from the homework in the packet, but your homework tonight is in Khan Academy. So what we're going to do is we're going to decide if these are either exponential or linear, and then based on that we're going to decide what is the equation of that line or whatever. So we can see that for example A, they are going up by 1s. It's going -1, 0, 1, 2, 3. So that's good. We can see we have our y-intercept here. And let's see, we're going from 4 to 7, 7 to 10, 10 to 13, 13 to 16. All of these are being added by 3. So since it's adding, we know that this is going to be linear. And then we got to think of the equation. So that's going to be y equals, because those x's are going up by 1, we can say that our slope is 3. And again, I could always show change in y over change in x, but this is a little bit of a shortcut. And then plus your y-intercept, which in this case is 7. What do we got on today? Is that Mackenzie in there? Hello. So let's try another one. Okay, so our x's are still going up by 1, so that's nice. I see my y-intercept, so it's always nice to circle that or identify it. And then let's see, we're going from 2 to 6, 6 to 18, 18 to 54, 54 to 62. That's clearly not adding. Those are being multiplied by 3. So since it's multiplication, that's going to be exponential. And the equation for this, remember with exponential, it's in that form y equals ab to the x, where a is like your y-intercept, that's starting initial value, and then b is the thing you're multiplying by. So we're going to have y equals, our initial is 2. Oh, my pen froze. Come on, pen. There we go. 2 times 3 to the x. So let's do a couple more. Any questions so far? Are we doing okay? Just stop me if I'm going too fast. Or if you're watching this later, you can pause. All right. So here, our x's are still increasing by 1, so that's nice. And this time I see that my y values are actually getting smaller. But it's not being subtracted by a constant. It's actually being multiplied by a half. So with exponential, we want to always look at it in terms of multiplying. So instead of saying divided by 2, we want to state that it's multiplying by a half. So this is exponential. So it can still be exponential even if it's getting smaller. It's just exponential decay. And then where's my y-intercept? It's 0, 8. So we have y equals 8 times half to the x. All right. Let's try another one. So x's are still increasing by 1. That's nice. This is getting smaller again, but it is being consistently subtracted by 16. So this is linear. My y-intercept happens to be at the origin. So there's a couple ways I could write this equation. I could say y equals negative 16x plus 0, but saying plus 0 is kind of weird. So you really could just write it as y equals negative 16x. Either is valid. If you want to write plus 0 because it makes your heart happy, go for it. You know, nothing wrong with it. Nothing wrong there. All right, so hopefully some of those examples help make what I was stating earlier a little bit clearer. Okay, next what I want to do is practice a little bit of average rate of change. Just because when we were graphing exponentials last time, we saw that it was on a curve. So like if I was to sketch this one right here, example C, if I was to sketch that, say that's my axis, it would look something like this. It would be a downward curve, whereas a line this one specifically goes to the origin, would look something like that. Very straight, rigid, shows that constant, whereas exponential, it's going to have a curve, whether it's decay or growth would be going up. So let's scooch back up to the regular part of the notes. I'm at the top of the second page of your notes if you printed these out. So it gives us the equation f of x equals 4 times 2 to the x. So I can see 4 is my y-intercept. And then I have a growth factor of 2. It's doubling each time. And we want to find the average rate of change. Well, remember, average rate of change is simply just change in y over change in x. So if we pick between 0 and 1, that means I need to use 0, 4 and 1, 8. I got to use those x values it specifically states. So that would look like 8 minus 4 over 1 minus 0. I could have gone in the other order, but I always like to start with the bigger one. Did I write 4? I did. Okay. Which is just going to give us a value of 4. 4 over 1 is just 4, right? Now, if I was to do the next one, it's 1 to 2. That means, oops, it's not a highlighter. Silly me. I have to use 1 and 8 and 2 and 16. So that would be like 16 minus 8 over 2 minus 1. So we really get 8 over 1, which is just 8. So we can see right there that it's not linear because that slope is different. So let's try another. It says from 2 to 3. So I'm going to use 2 and 16, 3 and 32. So I'm going to do 32 minus 16 over 3 minus 2. So I get 16 over 1, which is just 16. So there again, I see that my slope is different. It's not consistent. So that is showing you as well that it is exponential, not linear. Okay. Let me just show you kind of another visual because you might get some graphs on your homework in Khan Academy tonight. All right. So it says consider the linear function y equals 20x plus 5 and the exponential y equals 5 times 2 to the x. Both of these have a y-intercept of 5. So they start at the same location. So I'm going to graph the line first. And I'm just sketching it. Nothing perfect. But I do know that it starts at 5. So I'm going to get something that looks like this for my line. Okay. And then let me do the other one in blue. So it says y equals 5 times 2 to the x. So we know, again, this starts at 5. I can tell that this is growth because it is greater than 1. So if you have a number that's bigger than 1, even if it's 1.01, that is still exponential growth. If it's something that's less than 1 but still bigger than 0, you're going to have decay. So that's going to look something like this. So y equals 5 times 2. Oops. That was messy. To the x. So just to kind of give you again, what's the visual on that? All right. So again, your homework tonight is in Khan Academy. I hope that was helpful. It is due on Monday evening, and I think that's it. So if you have any other questions, feel free to email me, pop on my office hours. If my office hour time doesn't work for you, just email me and we will figure out a time to do it. So did I want to do C? No, I didn't. Okay. So have a fabulous day and have a good weekend.